Hi guys. Hi guys. Good evening. Can you hear me?
Good evening, sir.
Yes, sir, hearing.
Thank you. Yes. If anyone unable to,
Yes, we can hear you, sir.
yeah. Thank you. If anyone unable to hear me, just rejoin the session. Rejoin into session. Rejoin into session. Yes. If anyone unable to hear me, rejoin the session. Let us start session. Yes. Previous classes, day 1, day 2. Day 1, all the introductions. Day 2, Java introduction discussed. The Java history. Okay. About Java. Yes, Java history, Java features. These things were discussed. About complete Java. Java since 1995 to today, what was happened in Java discussed. Okay. The storyline, just like a storyline, this is okay. 1995 to today, Java storyline. What was happened in Java? The storyline completely discussed. Okay. Yes, today let us see about Java features. Let us start with Java features. Yes, JDK 1.0, first version of Java. Yes, first version of Java released with these features. Not day 3. Save. Day 3. Yes, JDK 1.0, first version of Java. JDK 1.0, first version of Java. First version of Java released with main features as below here. Like independent platform, portability, group language, scalability, and security. These are the main features of Java. Okay. Yes. Independent platform, portability, group language, scalability, and security. See, independent platform means OS. Independent operating system. Independent platform means independent operating system means Java running on any OS. Portability means Java application can be moved from one OS to another OS without any changes. Java is object-oriented programming language. For this thing here, simply just explaining definitions and going to Java programming. Yes, we can do like that. Just explaining definitions, giving definitions and going to Java programming. I can do like that here. But that is not my way. That is not my way here. Giving definitions and going to Java programming. No, that is not correct. Practically we'll see. Yes, independent platform. How Java made us independent platform? What is happening behind of this? Okay. Yes. To make it as independent platform, how OS is working, how JVM is working, that internals we should discuss. Okay. See, to understand these features here, yes, you must have some basics, some knowledge to understand it. To understand all of these features here, yes, you must have some knowledge, like OS knowledge. What is operating system? So what is operating system? How OS is working? About operating system. Yes, how OS is behaving. While running program, maybe C program running, C program, C++ running, Java program running, or Python. Yes, any program running, how OS is behaving. If you know that behavior, then easy to understand this concept. So about OS, next, about OS, next apart from this, yes, apart from this, Yes, about compiler knowledge. How compiler working? Java, depending on compiler or interpreter. That knowledge. For Java program, which one is working? Is it compiler or interpreter? Suppose C program compiler, Python interpreter. For Java program, which one is working here? That knowledge. So compiler and interpreter knowledge. You must have compiler and interpreter knowledge. Compiler interpreter knowledge. Okay. Next, apart from this, exe file knowledge. Exe file is a OS dependent. For Java program, it's independent of OS. Okay, exe file, C language, exe file, C++, exe file knowledge. In Java program is a dot class file. Okay, get this knowledge. Get these are the prerequisites. These are the prerequisites to understand your Java features. Yes, we know about this thing here. What is OS? What is compiler? What is interpreter? What is exe file? What is dot class file? If you know about this, then easy to understand this thing here. See here, without explaining all of this directly, I can explain definitions. Simply explaining definitions, going to Java program, no use. Just learning basics, no use. Learning definitions, no use. We'll see practically. What is happening inside the JVM? What is happening inside of OS? What is happening in the compiler? What is happening inside the interpreter? EXEVL dot plus. If you have all this knowledge, then easy to explain. Yes. Yes, in interviews, easy to present it. Easy presentation. For that more knowledge. If you have the more knowledge, then easy to easy to explain it. Let us see. So before going to the speeches here, let us see about these topics. Let us see about these topics. Okay. Yes. I'm starting from very basics. Yes, non-IT case. Non-IT case here. See, I'm starting from very particularly non-IT case. Okay. I'm starting from very basics. See, computer. Yes, computer where? Computer where? See, from the scratch, who don't have the IT background also can understand. Having IT background already, for them also this knowledge required. For them also this knowledge required here. Okay. What is computer ware? See, computer ware, there are two things. Yes, hardware. Yes, hardware. Next, software. There is a hardware and software. Okay, I think some guys are maybe wondering. Yes, starting very basics, starting from very basics. Okay, so what is hardware? Hardware, these are physical components of a computer. Hardware, these are physical components of a computer. Physical components like keyboard, mouse, hard disk, monitor, motherboard, all the RAM, all the hardware components we can touch. They are physical components. We can touch, but that is not our part. Our part is software. Our part is software. Okay, so let us start with software. What is a software? We are the software engineers. We are not a hardware engineers, so that is not required for us. Leave it. Leave about the hardware. Let us start with software. Software. What is a software? What is software? In software, yes, in software, everything is a program. Everything is a program. Everything is a program. Everything is a program. In software, everything is a program. Everything is a program. Everything is a program. Okay. Yes, it's a collection of programs. It's a collection. Yes, it's a collection of programs. It's a collection of programs. It's a collection of programs. Programs such as C program or C++ or Java, like different kind of program. It's a collection of programs. Software, it's a collection of programs. Once again, you guys don't write any running notes. It's not necessary. See, introduction to software. Started with basics here. Software, it's a collection of programs. It's a collection of programs like C, Java, SQL, and other programs. Okay, started from basics here. It's a collection of programs. Software is a collection of programs. See, software basically two categories. Software basically two categories. Software basically two categories. Software basically two categories. First one, yes, system software. Next one, application software. Application. Next one, yes, application software. System software. Next application software. System software, application software. Okay. Software basically two categories. First one, system software. Next is application software. What is system software? System software. System software. System software. It interacts. It interacts with hardware components. Interacts with hardware components. Interacts with hardware components. Just interacting with hardware components. Simple. It's very simple here. System software. It interacts with hardware components. Example OS. Example OS. Yes, operating system. Example operating system. Okay. System software. It interacts with hardware components. Yes, OS. Only OS interact with hardware components. OS. Operating system. Operating system means like Windows is a operating system. Linux is OS. Unix is OS. These are all the operating systems. Windows, Unix, Linux. All these are operating systems. Operating systems interacting with hardware components. Okay. Next, application software. Application software. Okay. Application software. So what is application software? Application software. See, application software. This is for the purpose of application development. For the purpose of application. For the purpose of application development. For the purpose of application development. For the purpose of application development. Application software for the purpose of, this is for the purpose of application development. Application apps. Yes, apps. See, in our daily life, we are using many applications. Yes, in our daily life, using many applications. Yes, what are the applications we are using? Yes, guys. Anyone, can you tell me some examples? Examples of applications. Examples of applications. Yes, in our daily life. Yes, our day-to-day life, we are using many applications. Tell me what kind of applications you are using. No, MS Office, that is no. MS Office is software. That is not application. Yes, WhatsApp, it's application. Best example, Facebook. See, 1 second. MS Office is a software. Paint is a software. That is so software. Applications. Yes, applications. Facebook is application. Yes, everyone using that. Facebook is application. Okay. Yes. WhatsApp is application. Facebook is application. WhatsApp application. Okay. Facebook is application. WhatsApp application. Next, Flipkart, online shopping. It's application. Next, company websites are applications. Yes, using for some purpose here. Websites, company websites, applications. Okay, right? Next, Zomato, food delivery app, right? Zomato. Okay, these are applications here. Okay, Twitter, it's application. Yes, YouTube, it's application. YouTube, it's application. Okay, next, banking applications, banking apps. All the applications, they're applications. Yes, Vola. Yes, all the applications. No, Vola. Okay, media player is also application. That's also media player. Media player also application. Application. Go to training, go to meeting. Yes, Zoom app. Go to training, go to meeting. These are all the applications. Okay, they are the applications here. Yes, to develop this kind of applications, we need some software. To develop this kind of applications, to develop WhatsApp or Facebook kind of applications here, this kind of applications, to develop this kind of applications, we need some softwares. Those are called as application softwares. Application softwares for the purpose of application development. Example, application software examples. Yes, best example, Java. Java is a mostly used application software. Java is a mostly used application software. Java is application software. Next, Hadoop. Hadoop is application software. Even database also application software. Okay, for the purpose of applications, we are using database. Okay, next Python. Python is application software. Like this, many things. Okay, yes. In software, there are many technologies. In software, there are many technologies. Yes, even .NET also application software. In software, there are many technologies. See, there are some languages. There are some tools. Yes, there are some packages. Yes, all the languages. Languages like C language. Even C language also comes on application software. C++. Yes, languages. Language like C language, C++, Python, Java, HTML. Okay, shell scripting. Yeah, there are different languages here. Next, tools like warehousing tools, testing tools, reporting tools. Next, AWS tools, DevOps tools, big data tools, many tools available. Okay, next packages like ERP packages like Oracle ERP, SAP ERP. Next, Tally. All these all are application softwares. See, like this, how many we can list out? How many? Yes, hundreds of softwares, right? Which is exactly application software. Simple here. Any software which is interacting with hardware, that is called as system software. Any software which is interacting with hardware, that is called as system software. Except that all are application softwares. Except that all are application softwares. See, only operating system can interact with hardware, others cannot. No. Java interacting with hardware, no chance. C language directly interacting with hardware, C++, .NET, okay, maybe SAP, yes, taking some tools. No one interacting with hardware, only ways. Only ways interacts with hardware components. So except operating systems. Except operating systems, all are application softwares. That's it. Simple. Okay, all are application softwares. Okay, all are application software. That's it. Simple. So which is application software except OS? Only OS is a system software. Only OS. Only operating system can interact with hardware components. Only OS is a system software. Except OS, all are application softwares. That's it. Okay. Yes. Yeah, device driver. No. Device drivers are part of OS. Drivers are part of OS. Drivers comes under system software. Driver is a system part of system software. Driver is also system software. Okay. Yes. See, simple. Anything which is interacting with hardware. Anything which is interacting with hardware. That is called as system software. Okay. Anything which is interacting with simple, just try to understand. Okay, anything which is interacting with hardware, that is interacting with hardware interaction requires. Yes, only ways will interact with hardware. Okay, only ways. Yes, suppose others. No, one second. Device driver is also part. Device drivers also interacting. Ways and device drivers. Okay, see here. System software, operating systems and device drivers both comes under system software. Both are system software. Device drivers are part of operating system. Device drivers also interacting with hardware. Device drivers also comes on system software. Device drivers also part of system software. Okay, OS and device drivers both are system softwares. Except this, all are application softwares. All are okay. See, same explain your document here. Software basically two categories: system software, next application software. System software, it interacts with hardware interacting with hardware components. Example, device drivers and operating systems. They are system softwares. Application software, except operating systems, everything is application software. Okay, except OS. Device drivers we are not using. The device drivers is part of OS. Just I'm considering like a part of OS. Device drivers are part of OS. We are not using that here. Device driver we are not using. OS internally using here. OS internally using device drivers. Okay, we are not going to use any device. OS internally using here. Okay, yes. So except simple, except OS. So except OS, all are calling as application softwares. Yes, about OS. Now our topic is about OS. Actually, Java comes on application of Java is application software. Java is application software. Yes, before going to application, our topic is application software. Before going to application software, let us see something about OS. Yes, about OS. See about OS. Yes, here some question for you guys. Some question. I should ask one question here. Yes, about operating systems. Some question for you guys. Some question. Question is. Question is. Can we run? Can we run any program? Any program without OS? This is question. Can we run any program without OS? Can we run any program without OS? Simple question. Can we run any program without OS? No. Answer is no. OS required compulsory. Then what is operating system? What is OS? Next question is what is OS? What is a OS? Let us see what is OS. Yes. Let us see about OS here. To understand independent platform. Yes. You really get. Yes, system software example is OS. So what is OS means system software. Okay, good. Okay. System software example is OS expand. OS given example. What is OS means saying that simply system software. Okay, good. Fine. Yes. Now what is exactly OS? What is exactly OS? Let us see. So what is exactly OS? See, suppose your system, your laptop. Suppose you purchase a laptop. Yes, you purchased a laptop. Okay. So when you purchase a laptop here, yes, they will set up OS. Hardware, that laptop vendor will set up OS. See, hardware, that laptop vendor will set up OS. Hardware, in your laptop, there is hardware. On top of hardware, there is a OS, operating system. Yes, operating system. Okay, there is a hardware. On top of hardware, there is a OS. So once OS setup is done, your system is ready. See, my laptop with OS. Now this OS is responsible. This OS is responsible to take any request. Suppose when I click on WhatsApp, OS is responsible to invoke this WhatsApp page. OS is responsible to call the yes launching this WhatsApp here. Suppose Eclipse. Once I double click on this, OS is responsible to launch the Eclipse. So OS is responsible for everything here. So every request goes to OS only. Every request goes to OS. Every request simply goes to OS. So for example here, for example, learning C language. Yes, C software you have to install on top of OS. So learning C++, that should be installed. So learning Java, that should be installed on OS here. So learning Python, that Python should be installed. Okay. Suppose learning some Hadoop, that Hadoop should be installed here. Hadoop should be installed on top of OS. So we're using database also on top of OS. See, all these are running on top of OS. All these are running on top of OS. C, C++, Java, all the programs running on top of OS. These are what application softwares. All they are what application softwares. All their application software. Okay. All these are called as application softwares. These are application softwares. All these application softwares, all these are running on top of OS. On top of OS. So OS it's giving platform. OS giving platform. It's giving platform to run all the programs. to run all the program. Just it's giving platform. On top of it, all are running. Without OS, we can't do anything. Compulsory OS required. Okay, hardware. On top of hardware, this OS. On top of OS, all the programs running. So it's giving platform. So OS is working like a platform. Okay, what is OS? Yes, simply it's a platform. It's a platform. It's a platform. What is OS means? It's a platform. What is operating system? What is operating system? It's a platform. It's a platform. Yes, where we can run all the application softwares, where we can run all the application software. That's it. It's a flat. Simply, what is OS means? Simple answer. It's a platform. On top of it, everything is running. Simple answer. It's a platform. OS is a platform. It's a platform where we can run all the application software. So everything is running at top of OS only. Without OS, we can't run any program here. Without OS means only chip level programs, BIOS program. Only BIOS program running without OS. I think you have some BIOS program, right? BIOS, basic input output. BIOS program, it's a chip level program. Once you power on system, first of all, BIOS program running. To run the BIOS program, OS is not required. That is chip level program. Okay, that is hardware level program. That's a hardware level program. For BIOS program, OS is not required. First of all, BIOS program starts. Now BIOS program loads OS into RAM memory. Just booting through the BIOS program only here. Okay. These all are software programs. To run these software programs, we need OS. Okay. Can we run any program without OS? Any program is software program. Software programs, not hardware. BIOS is a hardware program. Except BIOS, everything OS required. Only for BIOS, OS not required. Except BIOS, for all OS required. Yes, all are running in top of OS. All are running on top of OS. It's a platform. It's a platform where we can run all the application software. Okay. Yes, not only platform here. Suppose C program or Java program, Python. These programs generating some output too. These programs generating outputs. Okay, these programs generating output. This output delivers to OS. Output of all the programs delivered to OS. After delivered to OS here, then transport to output device where BIOS program stored. Chip, motherboard chip. In motherboard there is a BIOS chip. Okay, when you power on your system, that first of all power goes to that motherboard BIOS chip. Okay, signal goes to the BIOS chip. So a chip receiving power, on receiving power, BIOS program activates. That's it. Okay, BIOS it's a part of motherboard chip. Inside of motherboard there is a chip level program that is. Okay, yes. So here these programs, C program or C++, Java, Python, these programs delivering some output. So first of all, output goes to OS. Okay, and then transport to output device. Suppose reading from the keyboard. So first of all, keyboard data goes to OS. Keyboard data transferred to OS and then transferred to your C program or Java program. Okay, so between these programs and hardware, this is OS. So it's a middle layer, like a mediator, exactly calling as interface. Interface between application software and hardware components. Next, it is an interface. It is an interface. It's an interface. Yes, between. Yes, this is an interface. Yes, between this application software layer and hardware components. Okay, hardware components, right? Yes. So ways acting as interface between these two layers, application software and hardware is an interface. Way is an interface here. It's a platform and interface. That's it. Next, one more thing here. In OS, there is a library. Yes, every OS has its own library to communicate between application software hardware components. Library. In OS there is a library. What is that library here? Library is a collection of functions. Library is a collection of functions, input output functions. Library is a collection of functions, input output functions. Functions, C language functions. Functions means C language functions here. OS like Unix OS, Linux OS, Windows OS, all these applications were developed in C language. C language only here. All are C language functions. Library contains C language input output functions here. Library, it contains yes inputs, yes inputs and output functions here. Library contains all input output functions to perform IO operations. Okay, library contains all the input output functions. Okay, yes, here library, just using library to communicate between application software and hardware components. Okay, see every OS has has its own own library to communicate between application software and hardware components. Okay, yes, library OS using library. With the help of library only communicating between application software hardware components. Okay, next one more important point in Java perspective. Java perspective, some important points here. See here, C program or C++ or Java program, Python program. See all these programs, first of all these programs, first of all, links with OS library. Of linking with OS library, then it communicates with the hardware components. Linking. Okay, every program, maybe C program or C++, Java, Python, all of the programs, every program has to link with OS library before going to start. Before going to run it, it has to link. Okay, every program, every program, every program has to link with. Yes, remember this point. Java perspective is very, very important. Every program has to link with OS library, yes, before going to run. First linking with OS library, then running. That's it. Every program has to link compulsory. Every program has to link with OS library before going to run. Linking. Suppose C and C++. This is statically linking. C and C++ statically linking. Java and Python is a dynamical linking. Yes, we'll discuss. Practically I'll show. Statical linking. I'll show an example in C language. How statically linking. Next, we'll discuss one example in Python and Java also. How dynamical linking. How statically linking. How dynamical linking. The topic we'll discuss very clearly. Practically I'll show. Yes, I have very good experience in embedded C. That linking I'll explain very clearly. How that links to OS library statically, dynamically, practically, I'll show this. I'll develop one C program. I'll create one exe file. How that linking, what's happening, I'll explain very clearly. Okay. Yes. So every program has to link with OS library before going to run it. Suppose C and C++ statically linking. Java and Python is a dynamical linking. Yes, we'll discuss. Wait. So this is about OS. Yes, this knowledge enough, not more than that. To understand Java features, here, this OS knowledge enough here. This knowledge is enough here. Okay. Yes. See, system software, application software. See, in the system software, device drivers and OS. Device drivers, they are to communicate with hardware components to run the devices. Device drivers are to run the devices. Running devices, of course, not required for us. See, OS, about OS expansion. It's a platform where we can run all the applications of it. It's a platform, its interface. Next, every OS has its own libraries for communication purpose. Next, every program has to link with OS library before going to start execution. See, here these are the application softwares. Hardware, on top of hardware, this is OS, on top of OS, application software. See, output too. transferring here input to like this. Okay, output to application software to voice to output device, input to keyboard to voice to your programs. Next, linking. Okay, yes. What's the purpose we'll discuss? That is exactly our topic. What's the purpose of linking to voice level? That is actually our topic. Java independent platform. Java is independent platform. That is actually our topic. Before that, we are discussing the prerequisites. Prerequisites we are discussing now. Okay. Yes, what your question is or actual topic. We will discuss. Wait. Okay. So every program has to link with voice library before going to start execution. Yes. The topic collection practically. Why linking with voice library? What's the purpose of linking with voice library? We'll discuss practically. Wait. Practically also. So this is about voice. This introduction is enough. Okay. System software. Okay, next application software. Okay, about voice discussed. Enough. Now let us move to application software. Java is application software. Java is application software. So let us go to application software. Let us see about application software. See, yes. So applications. Now moving to application software. See, application software. There are two things: front end and back end. There are two things: front end, back end. What is front end? What is back end here? See. Yeah, this is front end. Okay, once again, go to training. In this, say this. See, this is form, some registration form, right? It's a registration form. Yes, we are filling this information on register. 1 second. Yes, only this week you have to fill this form and submit. Next week, not next. Next week, directly you can connect your connect to meeting here. Yes, someone asking why filling every day filling. Only this week required. This week go to training. Next week go to meeting. So that time filling details not necessary. Okay. Next week not necessary. Because why filling this week means collecting information, right? Yes, we should collect data from users, right? Yes, yesterday and today, about today also some new members joining here. Okay. Today some new members joining. Okay. So for that purpose, we have to collect data, right? Directly joining means we can't collect data. For data collection purpose, this week you have to fill it. Next week is not necessary. Next week is not necessary. Okay. Yes, filling form is not an issue. Just matter of I think 10 seconds. Within 10 seconds, fill and register. That's it. 10 seconds. What happens? Okay, just only spare only 10 seconds. Or just only 10 seconds. Fill within 10 seconds. Submit. That's it here. Okay. Yes. Now here, see, we are filling form register. Now this form is called the front end. This is front end. It's a front end. So collecting data. This is collecting data. This is collecting data from you and storing somewhere. Okay, this data collection. This is called the front end. So this front end interact with the end users. We are the users. We are the end users of this application. We are the end users. End user. Okay. So this form collecting data from us. Okay. So this is called as front end here. Front end. So front end collecting data from users here. Front end. So front end. So front end interact with end users. End users. It collects data from end users and stores in the back end. So what is back end here? Back end, yes, where the data storing. See, we are filling this information, right? This information go to somewhere and storing some location. Yes, all this information storing at some location. Okay. Yes, after finishing your class, now Durgasoft, they will take your data. Yes, your data, yes, storing some location, right? They will take data. After taking that, they will analyze, going for follow-up and all this. Yes, whether students are joining or not, the tracking, right? To tracking for data. Data where that stored here, some location. That location called as backend here. Backend is a location where all the data storing. Backend examples, databases and files. Backend example databases. Yes, in database storing data or files storing data. So this is front end, back end, front end, back end. Yes, what is Java? Java comes out of front end here. See, so behind of this form, Java program working, JSP working, Java server pages, JSP program working. That program taking your data means it's a front end. Java is a front end. Java is a front end. So let us move to front end. Our topic is now front end. Yes, in front end, there are languages and packages. In front end, again, two categories, languages and packages. Okay, package. It's a predefined ready-made one that it is. For example, MS Office is a package. MS Office, no coding. Next, ERP package like SAP ERP, Oracle ERP, no coding, direct using ERPs. Tally accounting package, there package here, direct to finish, no coding here, no coding. Language means we should write the code. In language, we should write the code. Java is a language. Java is language. So our topic is now language. Let us move to language. See, the way of introducing it is Java. How I am introducing it is Java. See that. First, computerware. Computerware. See, computerware. Yes, computerware, hardware and software. So Java comes on software. Software. Okay. Software. Java software. Yes. In the system software, next application software. Java is application software. So that's the reason move to application software. That's the reason move to application software. Move to application software. In application software is a front end, back end. Java comes on front end. See, front end, back end differences. See, front end, back end differences. Data where storing, that is called as simply back end. Except that remaining all are, we can say front end. Okay. Maybe language, maybe from whatever it is. That may be language, that may be tool. Okay, that may be language, that may be tool, whatever it is. Okay, data storage location is backend. Data storage location is backend. Except data storage locations, everything called as front end here. Okay. Yes, except data storage location, all are front ends only. Okay, even language collecting data from you, right? Language also has to collect data from you. Language also collecting data and storing it backend. Okay, so except backend means except storage locations, storage database files, the storage locations are called as backend here. Except storage locations, all are front end. Now Java comes under front end. That front end can be language or package. See that in front end, front end can be language or package or maybe some tools or sometimes tools also. Okay, now Java comes on language. Java is language, so that's the reason moving to languages. Yes, our topic is not languages. Yes, now let us start topic. Yes, from this very interesting languages. What is a language? What is a language? See, we are speaking many languages. Why are you speaking all the languages? Like English, Hindi. See, I'm using some English, right? Why I'm using English here? Communication purpose. Communication. Just a communication. Just it's a media of communication. What is language? It's a media of communication between two things. Okay, maybe two persons or two animals or two trees. Every living thing has its own language. Communication purpose. For the purpose of communication. Okay, fine. Now come to software. Yes, software languages. Yes. So what are the software languages? In software, there are two types of languages. First one, computer understandable language. Computer understandable. Okay. First one, computer understandable. Understandable language. Computer understandable language. First one is computer, understandable language. Computer understandable language, right? Second one, user understandable. User means we are the users. User Yes. First one, computer understandable language. Second one, user understandable language. So computer understandable language. Okay. Next, user understandable language. Computer, yes, user and only there are two things here. User and computer. User and computer. Okay, user understandable means like Java program is user understandable language. Suppose Java program. So test.java. Yeah, this is like English language. It's user understandable language. User understandable language. It's like English language. It's user understandable language. User understandable. Okay. Suppose for example C program. Let us take some C program. C program. Yes, here some C program. C program. This are like English language. Java program, C program, maybe Python scripting. All are like English language. All are like English language. So Python script, for example, here. Python script. Yes, English language. These are user understandable languages called as high level language. Looks like English language called as high level language. Next, computer understandable. What is computer understandable? This is point here. What is computer understandable language? Anyone idea? What is computer understandable language? That depends on your computer. Computer understandable language. Generation of computers. How many generation of computers? Generation of computers. Generation. Yes, even this also we are discussing. Generation of computers. How many generation of computers? How many generation of computers? Generation of computers. How many generation of computers? Generation of computers. Five generations. Even this also I'm explaining. This also I'm explaining here. Totally five generations. First gen. What is the first generation of computer? Yes. Suppose electronic case, maybe some idea about this. Yes, not only electronics, everyone must have. Everyone must have this knowledge. Generation of computers and generation of knowledge. Okay. See, all that history I will explain. I can explain. I will explain also in your classes. Okay, so complete software. Lot of information I can give you. No worry. First generation. What's a first generation? No. First generation computer. First generation computers is yes, vacuum tubes. Yes, vacuum tubes based computer. Okay, vacuum tubes based computer. First one, vacuum based computer. Yes, next second generation. Now tell me, what is second generation here? Second generation. What is second generation? Yes, vacuum tubes. Yes, here electronic case will study this. Okay, second generation, good. Transistor based. It's a transistor based. Transistor based. It's a transistor. It's a transistor based. Next, transistor based. Transistor based. Yes, next, third generation. What is third generation of computer? What is third generation? Third gen. Third generation. Yes, integrated circuits. Good. IC. Integrated circuits. IC based. Integrated circuits based here. IC based. Integrated circuits. Integrated circuits. Integrated circuits. Circuits. Next, what is fourth generation? What is fourth gen? What is, yeah, right? Microprocessor based, processor based, processor based, processor based. Okay, processor based. Now this is present generation. This is present generation. Present generation. This is present generation. Processor based, microprocessor or processor based. Like 8085, 8086, 8085, 8086, 8085 old processor, 8086 new processor. From since 90s we are using 8086. Next fifth generation. So what is fifth generation computer? Fifth generation. What is fifth generation here? Fifth generation is AA based. Good. AA based. Yes, fifth generation not yet released. Yes, in the year 2024. Yes, shortly hitting market. Yes, shortly. Yes, 2024 only 2 years left. Within 2 years, we are moving to AI based. Once AI based come to the market, yes, software becomes very simple, easy to work. Yes, easy to work in the software field. This much of writing code and this much of work is not necessary. AI will recognize everything automatically here. So much coding is not necessary. Much efforts are not required. Okay, artificial intelligence, AI based artificial intelligence computer. This will be releasing shortly, maybe 2024 expecting. Yes, almost testing and everything is done already here. Yes, maybe releasing, yes, in 2024. Just within couple of years only hitting markets. The feature this is now presently processor based. Now presently processor based. Okay, so what is processor based? Understand processor based computer. Now currently processor based computer. Okay, so what is processor based language? Processor understandable language. Processor understandable language. What is processor understandable language? Processor understandable language. So what is processor understandable language here? Processor understandable language. Here this is binary code. This is binary code. Binary code. So binary code means like a zeros ones format. This is like a zeros ones format. Okay, zeros ones format. Yeah, zeros ones, something like that. Zeros ones format here. Zeros ones format like this. Binary code. Okay, binary code. Yes. How this is converting into binary code, that also we'll discuss. I'll explain very clearly how that high level language converting into binary codes. That also I'll explain very clearly. How it's converting into binary codes. So for example, here 10 is a number. That number converting to binary code. Once converted, result is 1010. For 10 binary code is 1010. For 10 binary code 1010. For 10 binary code, 10 is a, yes, this our language, right? User understandable language. Numeric value, numbers. User understandable means our language. That our language converts into system understandable language. System understand binary code. 10 converting into 1010. How that converts, we'll discuss next. In Java, I'll explain. In Java, we have the bits and bytes concepts. Okay, separate class is there. In memory, how bits and bytes, how it's converting here, we'll discuss very clearly. See, every topic I'll touch. Don't worry. I'll go in depth here. Every topic. Lot of information I will give you. Don't worry. Every information, particularly non-IT guys, non-IT background guys, even don't have IT here, you'll get all these skills. Yes, maximum I'll try to get all these skills. Okay, this processor based computer. Yes, it's a binary code. Now this is system understandable language. Okay, yes, computer understandable is a system understandable called as low level language. User understandable called as high level language. Yes, software languages, software languages. Basically, basically two categories. First one, low level. First one, yes, low level languages. First one, low level languages. Second one, high level language. Second one, yes, high level languages. Low level and high level language. Low level and high level language. Low level languages. Yes, low level language. It's a system understandable language. It is a system understandable language. Okay, yes, it is in the form of binary code. It is in the form of binary code. It is in the form of binary code, like a zeros ones format. Yes, system means what? It's a system understandable. System is your computer understandable. System means processor. It's a processor understandable language. Processor is like 8085 and 8086. Now currently we are using 8086. Old one is 8085. Now we are using 8086. Yes, in 90s, from the 90s we are using 8086. 8086 processor. Okay. Yes, it's a binary code. Okay. This language called as machine language. 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 Machine language, low level languages, machine language. Next, one more language, this assembly language. Assembly language, this also compared to understandable language. So assembly language somewhat easy compared to machine language. Assembly language somewhat easy. These two are low level languages. Okay. Yes. Now 8086 is a processor name of the processor. 8085 based and 8086 based. It's a processor that is electronics, that is not required for us. Enough. 8085, 8086. A processor names, name of the processor, name of the core is different. That is different. Core is different. Okay. 8085, 8086. Okay. Yes. Now we are using 8086 computers. Okay. The processor 8086 processor. Yes, 8086 language. Yes, we should go to electronics again. That much is not necessary. This is enough. See, machine language, assembly language, they are system understandable language. They are computer understandable languages. So these are not required for us. We are not going to learn about this language. Just we are, yes, just for knowledge purpose. What is low level language? What is high level language? Knowledge, just for knowledge here. Okay, learning machine language not necessary. Learning assembly language not necessary here. Okay, just for knowledge. So low level languages, machine language, it's in the form of duration one. This is called binary codes. Machine language. It's a system understandable language called as machine language. It is called as. Yes, it is. Yes, it is called as. It is called as. Yes, it is called as machine language. Duration one's format. Binary code. It is called as machine language. After machine language, one more language developed. Assembly language. Okay, assembly language is assembler based. It's assembler based. This is somewhat easy here. Assembler based. Yes, leave it. Not necessary for us. Low level language. Next, high level language. High level language. So, what is high level language? High level language. Yes, it's a user understandable language. It is a yes user understandable. It's a user understandable. It's a user understandable. It's a user understandable language. It's a user understandable language. It's a user understandable language. High level language. Yes, it is a user understandable language. It is a yes, it is a user understandable language. Understandable. Yes, user understandable language. It's like English language. Yes, it is like a English language. Yes, it is like a English language, like English language. Okay. Yes. Which is first high level language? Any idea? Which is first high level language? Which is first high level language? First machine language. Next assembly language. Next high level language. Which is first high level language? C language. Yes, C language. C language is a first high level language. C language is a first high level language. High level language. C is a first high level language. C is a first high level language. After that, what is next one? C++. After C++, next what? Python. Okay, like that. Yes, even that generation also I'll explain. Yes, year wise, every language. I'll explain very clearly. When C language developed, who has developed? C++, Python, Java. Like there are different languages. There are some different languages. Okay, there are some different languages. All that we'll discuss. Yes, before C language, already B language is there, but B language is there but not used. Okay. Yes, before C language, already B is there. B language is there but not used. Before B language, one more thing. Yes, one more thing. Algol language is available. Algol language. Algorithmic language. Before B, already Algol is there, but no one used here. B and Algol not used. Okay. First algorithmic language, next B language, next C language. Okay, only C language used here. Before C language, that language not used. So first high level language, C language. First high level language. C is a first high level language. Okay, fine. Now here question is here. High level languages. High level language. Maybe Python scripting. Yes, maybe C programming. Yes, maybe Java. These are all are high level languages. This high level language has to convert into binary codes. Every high level language program has to convert to binary codes. Yes, high level language to binary codes. Yes, it has to convert, otherwise cannot execute. High level language to binary codes. Every program has to convert into binary codes. After converting into binary code, system can understand, can execute here. Who will convert? Yes, anyone idea? Which one will convert from high level language to binary codes? Which one will convert from high level language to binary codes? Yes. Which one will convert? Which one will convert here? Yes, either interpreter or either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler. Yes, leave about Java compiler, not Java, just interpreter compiler. That may be Java compiler or C compiler or C++ compiler, maybe interpreter, something like this. Either interpreter or compiler. Yes, either interpreter or compiler converts. Yes, converts. Yes, converts from high level language to binary codes. Okay, either interpreter or compiler converts from high level language to binary code. Okay, yes, interpreter and compiler. This is very important topic and interesting also. Let us see interpreter and compiler. Interpreter versus compiler. Now topic is about interpreter and compiler. Yes, anyone idea what is interpreter, what is compiler? Anyone can tell me at least one difference? At least one difference. Yes, who is already, yes, I'm not asking about non-IT background guys. See, non-IT background guys, you don't worry. I'll explain everything here. Already who is having some knowledge like C knowledge or some already computer science background, who are complete engineering computer science background, yes, that case I have to answer this. That case how to answer. Interpreter and compiler, what's the difference? Yes, interpreter and compiler. Interpreter versus compiler. Yes, good. Okay. Some answers giving good. Yes. Yes, I like it. Your response. Yes, respond good. Okay. Good response. Interpreter versus compiler. What is interpreter? What is compiler? Let us see. Interpreter. First, let us start with interpreter. See, interpreter and compiler. Interpreter and compiler both are converting from high level language to binary code. Both are doing same process, but the way of its working is different here. Same process, but way of doing is different here. Way of doing is different. How interpreter and compiler working? First, let us start with interpreter. How interpreter working? See, you guys try to understand very clearly. This is very useful topic for Java. This is very useful topic for Java. Okay. Yes, if you understand this well here, then easy to understand Java. Okay, why I'm explaining all of these are all of the prerequisites. These all are prerequisites to understand Java. Prerequisites. Okay, interpreter. For interpreter purpose, suppose I'm taking Python. Okay, Python source code. For example, Python source codes. So test.py. Python script. Python. One second. Some Python example. D drive, mn drop Python folder here. Some test script is available. Yes, D drive, mn drop Python. So for this, yes, for Python application development, you can use this one here, PyCharm. There is PyCharm. Yeah, this PyCharm we can use. but you can't understand at this stage here PyCharm. Yes, see, I'm using command prompt, CMD, command prompt. Yes, D colon, go to D drive. In D drive, what's location of Python? Yes, mnra D drive mnra Python. So D drive DER. So mnra Python. This is mnra Python. Yes, now see change of directory. Change of directory. Python CLS. Yes, in this Python script. Test.py. Yes, notepad test.py. Yes, open. So the script A equal 10, B equal 20, C equal to A plus B. So addition. Next, this is subtraction. This is multiplication. Addition, subtraction, and multiplication of two numbers. Okay, fine. Now this program directly running. Now Python. That Python is interpreter. This Python is Python interpreter. Python interpreter taking your test.py the Python script directly executing. Yes, executing. Yes, executed. Suppose if C program is not like that. First of all, it will compile the C program, checking for all the errors. If no errors, then execution starts. So two steps: first the compilation, then execution. First the compilation. First of all, checking for errors. If no errors, then execution. But in case of interpreter here, in case of interpreter Python, directly program execution. No errors, checking nothing here. Directly execution here. Program executing directly. Here. Yes, how this script is working here. How that interpreter is working. See, script. This Python script here, how the script is working. See, the script, how that Python script is working. Script, subscript, first line. Yes, next step, A equal to 10, B equal to 20, C equal to A plus B. Print, display C value here. Next, C equal to A minus B. So print C, the statements. These program statements. Yes, these program statements. A equal to 10, B equal to 20, C equal to 8. These statements, all these statements. These statements, how working? Okay, how these statements are working? How this interpreter is working on this? How this interpreter working on this? So next line, next line, like this. Yes. How interpreter is working here? First of all, interpreter checking first line. If first line is correct, this code simply converts into binary format. That code simply converts into binary for zeros ones format and given to processor. Yes, processor will generate one output here. That's it. So what is happening here? Yes, there is no error checking initially. No error check, directly working. No error checking here, directly working. What happens here? Interpreter checks the first line. So first line is correct. Immediately converts into binary code and given to process generating output. If correct, executes over. First statement over. See, next coming statements may be right or wrong. Next coming statements may be right or wrong. Interpreter never think about next coming statements. Next coming statements may be right or wrong. Interpreter never think about next statements. Yes, first statement is correct. Immediately converts into binary code and giving output here. Okay. Next after that. So first statement completed. First line is over. Now next I'm checking for next line. Suppose next line also correct. Same converts into binary code. Given to process generating output. Second line also correct. Executes and giving a checking and execution. Checking then execution. First line check it and over, execution over. Second line checking, execution over. So line first line, next line. Next after third line here. Third line checking then execution. Third line of checking and execution. Suppose something wrong here, simply stops. That's it. If any error comes, simply stops. Any error comes, interpreter stops. Any error is there, interpreter stops. Let me show that practically here. Yes. Notepad test.py. Yes. Suppose some mistake. Suppose comma missing here. Okay, here suppose some bracket missing. Suppose this print, this bracket missing. Okay, suppose here double quotation missing. Total 3 errors. In total program, there are 3 errors. 3 errors. Now save. Save. After saving, now let us run this. Yes, no comparison. Directly running here. Directly, no errors checking. Directly running here. Directly running. See, 7th line error stop. Yes, first error stopped here. Still 2 more errors are there. Only 7th line error stopped here. Other errors not displayed. Any error comes simply stops. Any error. Any error. Any error. 7th line error simply stopped. 7th line error simply stopped. Now correct that mistake here. 7th line error. Correct that mistake. Yes, correction. Yes, correction is done. After correction. Yes, after correction. Now run it. Run it. Yes, 1 second. After correction. Now run it. Yes, run it. Now next error. 11th line error. Means only one error. Actually, still errors are there, but not showing all the errors. Only one error. Any error comes simply stops. Any error comes simply stops. Now 11th line error. See, I'm using up arrow key. See, without typing commands, up arrow key. Up arrow key. Already commands you right. By typing again every time. By typing is not necessary. Up arrow key. History. It will maintain history. Up arrow key. Yes. Now this is next. Let us correct this mistake. Suppose this bracket. 11th line error. 11th line. Save. Save. Okay. Yes. Now run again here. Again. Next error. 15th line error. So means only one error. This showing only one error. Only one error. Only one error. Okay. Now correct this mistake. Next mistake. This one, right? This is 70th line error. 70th line. Okay. Yes. Okay. Right? Yes. Now run it here. Run it. It's working fine. That's it. This is working of interpreter. What happens here? Interpreter checks the first line, correct, executes. Next correct executes. Something wrong, simply stops. This is working of interpreter. Interpreter working is line by line. First line checking, then execution. Second line checking, execution. Third line checking, then execution. Any error, simply stops. That is interpreter. Next compiler. Yes, for the same, how compiler working? For compiler purpose, let us take C program. Yes, C programmers will see practically. Yes, compiler. Compiler, yes. Compiler. Yes, C program source code. C program source means our programs. These are called source codes. This is source code. We are writing some program, right? Our code is a source code. This is source code. Now C program source code. Okay. Suppose some test.c. Some test.c program. Yes, how it's working. So there are some statements like how it's working here. C program. If it is C program, first compiler. C is a compiler base. First compiler is checking first statements. Suppose first statement is correct. Even it corrects, it won't convert into binary. No, it won't convert into binary codes. It won't convert. Checking for next statement. Next statement also correct. Even correct, it won't convert into binary code. Next statement. Suppose next statement is something wrong here. Error yet, third line. Error yet, third line. After that, checking for next statement. Suppose next statement is correct. Next, going for next statement. Like this top to bottom. Compiler checks the whole program from top to bottom. Whole program from top to bottom and shows all the next error may be here at this location. Compiler checks the whole program from top to bottom. All the line checking here. Whole program. Compiler checks whole program from top to bottom and shows all the errors. It shows all the errors. Checking all the lines or at a time. Whole program from top to bottom. Checking all the lines and shows all the errors. All the errors. All the errors. All the errors. Okay, let us see this example also. Compiler C program. Some Windows based C language. Next Linux based also I'll explain. Windows based. See, this is this program. Okay, so this is yes main function. Here there is a main function. Main function. Yes, saved. See, program to add, subtract, and multiply two numbers. Yes, enter files, main function int ABC variables. C enter first number, second number. C enter first number, second number. C equal to A plus B. C equal to A minus B. A into B like this. This is program. Alt C compilation. Just I'm comparing. Only compilation, no execution. Only compilation. Compile. No compile menu. Success. No error. Press any key. No alt or run. No running here. Yes, program executed. Enter number 10. Enter number 20. That's it. Completed. Suppose here let us do some mistakes here. Some mistakes. There are some mistakes. Suppose here some semicolon missing. Okay. Suppose scanf here comma missing. Okay. Suppose here printf. In printf this double quotation missing. Okay. Yes. Suppose this printf here bracket missing. Okay. Yes. Suppose here this bracket missing. Yes. Now F2 saved. Alt compile. See this errors. How many errors? 9 errors. Just showing all the errors, right? Interpreter only one error. This is showing all the errors. See enter key. See that errors. See at the bottom 16th line error. Next line error. Next 22nd line error. 27th line error. 29th line error. Like this all the errors. All their top to bottom, right? It shows all the errors from top to bottom. Compiler checking whole program from top to bottom and shows all the errors. All the errors. So next you have to correct all the errors. Correction of errors. Suppose error correction. Semicolon. Okay. Yes. Error correction. Suppose here comma missing. Comma missing. Okay. Yes. Next. Suppose here double quotation missing. Okay. Yes. Next here. Yes. Here some bracket missing. Here some bracket missing. Bracket missing. Next get here are some bracket missing. Okay. Now save. Saved here. Yes. Overwriting. Compile. Yes. Success. No errors. No errors. Next run it. Yes. 10, 20. Now what is happening exactly behind of this? What is happening? Let us see. Exactly what is happening here. What is happening here? So compiler checking whole program from top to bottom. It checks whole program from top to bottom and shows all the errors. Suppose correction of errors. Suppose all the errors correction. After correction, recompilation. When recompiled here, everything is fine. Suppose this is correct, no error. So next statements like this, all is correct. Suppose next, this also correct. Yes, next one, this also correct. Then what happens here? After compilation, if no errors, then compiler opens another file. It opens another file. Compiler opens another file. Compile opening another file. It opens another file. After opening another file here, this whole code, all the lines converts into binary format right to this file, like zeros ones format. So next zeros whole code converts into zeros ones binary format, zeros ones for binary language, binary format. Yes, all this code top to bottom, all the lines converts into binary code and write to another file, write into another file. This complete code, that complete code convert into binary code and write to another file. This file is called as exe. Executable file is generated from exe file. Yes, exe means executable. Executable file called as binary code, system understandable language. Now this exe file given to processor. Now processor taking that exe file and generating output, simply generating output. So processor taking that exe file, generating, so at a time getting output, at a time giving output. That's it. Now what is the difference after here? Interpreter, first line taken, then executed. Next line taken, executed. Next line taken, executed. What is compiler? See, on the second file generated. Let me show that. See, this program math.cpp. math.cpp. This program name is math.cpp. 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 So behind of math.cpp, let us go to backend. C drive. Yes, Control C, Windows based. In yes, here math.cpp, math M. Yes, math. See math.cpp, cpp, C, both are same. See this math.cpp file. This is our program. Backend also you can open and see that. This is our program. Math.cpp. Okay. Yes, now this program, how it's working here. So math.cpp. See, first compiling. See compilation. Alt C. Compiles. After compilation, now run. Alt or run. See here backend. Math.exe file generated. Application. Math.cpp file behind of this. Yes, when you're running this here, after compilation, it generates exe file. It generates one exe file. That exe file executing math.exe file application.exe type of file is .exe file. That exe file generated. Exe is a binary code file. Okay, exe file is a binary code file. Now this binary code linked with voice library. The topic later we'll discuss. It's not right time to touch it here. Next we'll discuss. So exe finally one exe file generated. That exe file executing now. That exe file executing. That exe file executing. Enter number. Yes, first number, second number. That execute. Exe file executed. So first source code converts into yes. That so all the complete source code. That complete source code converts into binary code. Right to one file here. That file is called as exe file. Generating exe file. That exe file given to processor. So processor taking that exe file, executing and generating output. That's it. This is difference between interpreter and compiler. Yes, one second. For better understanding purpose, let me compare these two. Yes, let us see points wise. Last 5 minutes over, almost over. Last 5 minutes. Yes, interpreter versus compiler. Let us see the differences here. Yes, interpreter. Interpreter and next compiler. What's the difference? Interpreter and compiler. Difference between these two. Interpreter versus compiler comparison. First one, yes, interprets. Yes, it checks line by line. It checks line by line. It checks line by line. One second. One second. Just a minute. Just a minute. Yes, interpreter. It checks line by line. Compiler. Whole program from top to bottom. Whole program. Whole code. Whole code from top to bottom. From top to bottom. Okay. Interpreter checks the code line by line. So interpreter checks the code line by line. Okay. Yes, compiler whole code from top to bottom. Next. output generation. Yes, it generates outputs. It generates outputs line by line, line by line, line by line. Compiler at a time outputs. See, compiler is creating one exe file. Yes, at a time, right? At a time output. It's at a time outputs. Compiler creating exe file and at a time giving outputs. Next here, interpreter, it shows only one error. It shows only one error. Only one error. Yes, all this is practically showed. Practically discussed, right? It shows only one error. Yes, compiler. It shows all the errors. It shows all the errors. All the errors from top to bottom. All there from top to bottom. Okay, from top to bottom. Interpreter, any error comes simply stops. Interpreter, any error comes simply stops. Compiler shows all the errors from top to bottom. Okay, next, main difference. Main difference, exe file. Yes, it does not generate. It does not generate. It does not generate exe file. Yes, compiler, it generates exe file. It generates exe file. It generates exe file. Interpreter does not generate exe file. No exe file. Python scripting directly executed. No exe file. Compiler, it generates one exe file. That exe file executing. Okay, interpreter. Yes, it executes. See, it executes source code directly. It executes source code directly here. Executing source code directly. That executing source code directly. Executing source code directly. See this Python script. Okay, that code. Yes, directly executing it. No error checking, nothing. Directly .py file. So it's a source code. The source file executing directly. Source code executing directly here. But compiler, it executes exe file. It executes exe file. It executes exe file. This next difference. Just main difference, these 2 points. Exe file is a main difference. Okay. Yes, next here, interpreter based languages are called scripting language. They are scripting language. They are scripting language. Scripting language. These are programming language. Programming. Yes, programming language. Programming language. Scripting and programming here. Programming language. Scripting, programming. Scripting means that can be modified anytime. Scripting means can be modified anytime. Scripting means that can be modified anytime. Programming you can't modify. You cannot modify. Yes, we'll see. Going forward, we'll see all what is script, what is programming. Yes, once you enter into Java, you can see all the differences. Script and program difference. Script can be modified, but program cannot be modified. Okay. Yes. Yes, why programming not modified? Tomorrow topic also. Script can be modified. How possible? Programming cannot be modified. How regions? Tomorrow topic, that is tomorrow I'll explain here. Okay. Yes. So interpreter based language, scripting language, compiler based are programming language. Interpreter based language, scripting language, compiler based is a programming language. Yes, for these examples, interpreter based language examples. Python is the best example. Python, HTML, Linux shell scripting. Okay. Next PHP. Next Perl scripting. Next JavaScript. JavaScript is not a Java. JavaScript is different. Java is different here. JavaScript is a browser understandable language. JavaScript is a browser understandable language. Java is a JVM understandable language. Java is different. JavaScript is different. JavaScript is not a Java. JavaScript is not a Java. JavaScript is different. Java is different here. Okay. Programming language examples. Yes, examples. Yes, C language. Next C++. Next .NET. Yes, .NET, C#. Okay. So scripting language and programming language examples here. Okay. Yes, here interpreter based language. See interpreter. Yes, interpreter. Yes, interpreter. See interpreter. Interpreter based language. Language don't have exe file. Don't have exe file. Interpreter based language, maybe Python scripting, no exe file. HTML code, no exe file. Shell scripting, no exe file. Interpreter based language don't have exe files. Compiler based, everything is exe file. Here everything is an exe file. Everything is an exe file. So this is difference between interpreter and compiler. Okay, interpreter line wherein compiler whole code at a time. Interpreter only one error shows, compiler shows all the errors. Main difference exe file. Interpreter no exe file, compiler based exe. Compiler generates exe. Interpreter does not generate exe. A scripting language, these are the programming language. Okay, scripting language examples, programming language examples. Now you're wondering here something, maybe some guys are wondering, where is Java? Our topic is Java, right? Actual topic is Java. Where is Java? That is question now. Now question, Java, is it interpreter based or compiler based? Yes. Anyone idea? Compiler, is it interpreter based or compiler based here? Java, is it compiler based or interpreter based? Anyone idea? Maybe in your college learned, maybe somewhere maybe heard about it. Is it compiler based or interpreter based? Compiler based or interpreter based? Java. Java depends on what? Java depends on what? Depends on Java depends on both compiler as well interpreter compiler as well interpreter. How can I explain this? Depends on both. Java depends on compiler as well interpreter. So based on what you're saying here? Based on what? Yes, we are saying the topic tomorrow we'll discuss. Okay. Yes, some guys are already leaving. Okay, let us stop the class for today. Yet tomorrow we'll continue here. Yes, Java depends on both the compiler as well interpreter. Java depends on both the compiler as well interpreter. This is tomorrow topic. Tomorrow we'll discuss here. See, today topic, it's there in document here. Every topic is in document here. Interpreter and compiler, the differences, all the differences prepared in document. Yeah, just you can see document, you can go to the document here. This document for you only. I'll share this document. See about Java. Java depends on both the compiler as well interpreter. The topic about Java topic. Yes, next half an hour required to finish this topic here. So tomorrow we'll discuss. Tomorrow about this one, and next let's moving to independent platform. How Java made us independent platform. Yeah, that's all. So we'll continue tomorrow. So thank you guys. See you tomorrow. Yes, have a great night.